And first up, we have Amanda. So Amanda, like she mentioned, is the Director of Programs at DMDII. And she loves the fact that she has moved from manufacturing to consulting and today to running programs on Future Factory. I think she's got a pretty wide perspective, so over to her.
All right, great.
Yes, let's go ahead.
Okay.
Yes.
Awesome. Thank you. So thanks for the introduction. Let's see, where should I stand? I guess over here. So thanks for the introduction. So I'm Amanda Quick from DMDII. I run a lot of our programming at DMDII. So if you have any specific questions on what that means, it's our Future Factory initiative, our cybersecurity hub for manufacturing that was recently announced, as well as a lot of our workshop programming. But really what I want to talk to you guys today about is the fourth industrial revolution and what it means to DMDII. And so we, before I get into all of this, I'm not sure if all of you are familiar, but Deloitte produces an annual global manufacturing competitiveness report. They've been doing it, I think, roughly for the last decade. In this report, every year, it's released every 3 years, but there's been one country that's come up as the top, as the leader in manufacturing competitiveness, and I'm guessing around the room we could all guess it's China. So China is the most competitive market for manufacturing right now. So that's low-cost labor, the infrastructure and technology development that's happening. But what's really interesting to us is in the most recent report, there's a new rising star. And that new rising star is actually the United States. And all of us may look at each other and say, well, that doesn't make any sense. I never think about the US and being a competitive manufacturing environment anymore. Those days are long since gone. So really, why that is the case is because of the fourth industrial revolution. It's IoT, it's AI, and it's cloud computing, and all of these technologies which really drive an opportunity to make the next big leap in overall manufacturing competitiveness. And so you may say, okay, well, why the US? It's really favoring the US as well as other Western countries. So countries that have a deep ecosystem in innovation through university networks, through startups, through places like this, places like DMDII, are actually favored to make measurable progress and be some of the early adopters of a lot of these digital technologies that can really transform and are part of this fourth industrial revolution. So DMDII is based here in Chicago, and we have a membership base of roughly 300 or so members, and a lot of people come to us to try to make sense of digital noise. So a lot of them are already really heavily investing in industry 4.0 type technologies. They're well along their roadmap, but they're trying to figure out, how do I separate hype from reality? How do I make sense of what's out there? And how do I actually take this and translate it into practice? And so that's really why a lot of our members come to us. And what we've done is we've convened this extensive partner network that brings together disparate kind of industries. So anything from aerospace to consumer packaged goods to chemicals to universities and startups to work together and collaborate to solve problems that are bigger than any one organization can solve on their own. And so we are part of 14 national institutes that were set up over the last 5 years. And our focus is on how do we make manufacturing more competitive now. So like, how do we help realize that vision that Deloitte set forth, which said the US could be a new leader in manufacturing competitiveness. So we're really loved that report because it creates a real immediate challenge that all of us can work together to try to get there. Still a long way to go, don't know if it will happen, but it gives us a vision and something to work towards and a huge opportunity. So when we put this into perspective, what does the fourth industrial revolution really kind of mean? This is roughly 2,000 years of economic history. So you'll notice the first 1,700 or so years have been largely compressed. Those were the years where roughly, I think, $300 per capita per person was generated in almost every economy across the world. It was just extracting goods from the earth for food, for shelter, to make tools. And then we see these inflection points So then we see these inflection points that happen when we have steam is introduced, electricity is introduced, and computers. And we see that the countries that adopted these technologies saw huge growth in wealth creation. And so where we are today, the US has roughly $70,000 per capita in wealth creation in this country. And these first three industrial revolutions were really focused on how do we exploit mechanical leverage to augment humans. So how do we create, electricity that allows us to have machines that can do work, versus the fourth industrial revolution, which is really focused on cognitive leverage to build self-learning systems. So how do we use IT and data and AI to really create systems where humans and machines interact together, where we can create learning loops, where we can continuously improve over time. So this is why we care, because that is a huge inflection point that could really take us to the next level in terms of wealth creation in this country. So with this said, and with that backdrop, what we've worked with our members on is a vision for the US manufacturing, which is every part better than the last. So what does that mean? So that basically means what we want to try to do is using data and information and everything, all sorts of data across the entire product life cycle. How do we take that information and feed it back into the process so that we can, in the very next instant, make each part better than the last one that was produced? So how do we take the learnings all the way through and compress the product development life cycle as short as possible? Better could mean a lot of different things. It could be better cycle time, it could be better quality, it could be better less energy consumption. Better can mean a lot of different things, and this can apply at both a kind of micro level on an individual process or individual machine, or at a much larger kind of macro level. But what we like about this is it creates a challenge for us to think about how do we get to something where we can make every single unit that comes off the line better than the one before it. And this is, I think, if you can start to do this, it creates huge economic potential. And when you start to do this, and if you couple this with the concept of the transformation economy, is really where you can see the most value. So transformation economy, for those of you who are familiar with it, there was, I think it was Pine and Gilmore wrote a book, it's called The Experience Economy, I think, and there's basically 5 different economic business models that exist, and here's what they are. So basically, at the lowest level, there's commodities, which are things you're extracting from the earth. So in this case, an example of coffee beans, you may be, for a cup of coffee, it may be 1 to 2 pennies is the value in that. And then you have manufactured goods, which is taking those commodities and transforming them and adding additional value. So in this case, it could be, okay, we're going to roast those coffee beans, we're going to grind the coffee beans, and now they're worth maybe a dime. And then you start layering on different things to add service to that. So service means, okay, maybe I just go down to a local diner down the street, nothing fancy. They now brew me that cup of coffee. Now I maybe pay $1 for that. And then when you start to think about, okay, how do I start wrapping experiences around that brewed cup of coffee? That's where Starbucks comes in. That's where you think about the experience that you actually get. My free Wi-Fi, my public restrooms, a great place to meet others, have business conversations. You've now created something where they can charge even more money. But really what we want to get to is these transformations of the economy, which is basically like the utopia, if you will. So we may not ever get there, and companies are kind of all racing on this journey to get here, which is how can we couple our customers and our products as closely together as possible. So how do we use customer insights and data and information about our customers to drive even better products? And when you may kind of say, well, where are you going with this? You've talked to me about Industry 4.0, making every part better than the last, and now we're talking about customer experience. Well, those are very important concepts, because if you can start to make every part better than the last, you can actually start to do the mass customization that's required in this transformation economy. So you can then really, really derive the value, because you can start to go to a batch size of 1 and a product development cycle of 0. And so really that's what I'm talking about, and that's why this is important. And we see a lot of examples, no companies here exactly, but a lot of companies are starting to move in that direction. And we really think that's where the economic potential and the economic value is going to be driven from, is companies that can do both these things. Make every part better than the last using digital manufacturing technologies, IoT, AI, machine learning, and then couple that with customer experience to really create big transformations. It's what makes me excited. So I wanted to give a couple examples. So some of you, I think I heard people over in like smartphone or telecommunications in here, may have heard of this company, Shomai, which is a Chinese company. It's been around for about 8 years. And the reason I bring them up, so you may have heard because they've been in the media, they're looking to enter the US market. What's interesting is they entered the cell phone industry 8 years ago, smartphone industry, which I would say is probably at the peak of competitiveness in that industry. So you had Apple and Samsung, and so why would you enter that market? Well, this company really entered the market on the premise of an agile product development lifecycle. And so what they do is they've set up a virtual network where they get feedback and concept ideas from their customers, and they regularly take that information and those concepts and iterate, and they're releasing hardware and software updates really regularly. Okay, so how regular is regular? They're doing it every week, and so every week is huge, and this is both on a hardware and on a software end. And what that's done is they've been able to compress the batch sizes that they're producing in their hardware, make these changes very quickly to meet the needs of the customers, which has done a couple of things. One, it's created a scarcity and urgency for customers. They want to buy the newest, coolest model, and it's changing so fast that people are upgrading very, very quickly because they want the latest and the greatest, or it was my idea, or I thought that was a cool idea, so I want the model with that. So it's basically made your customer base co-founders, if you will. And it's there's another thing I was going to say, which I can't remember right now, but so their development cycle is just so fast, which is really moving into that transformations economy type thing that we want, and also moving closer to that every part better than the last. And how do I take the insights and how do I change my product to meet the needs of the consumers? So because of the things that they've been doing, they've had 74% unit growth. Yeah.
I see this all the time,
Yeah.
especially in the Asian
Yeah.
area, China, and especially South Korea,
Yep.
where they put kind of crap products out there first. The product life cycles are so fast that they ramp up very quickly.
Yep.
And that's a little bit a very different philosophy from what we have. Put out the highest quality product, maybe a little bit slower.
Right.
So I think that mindset needs to shift a little bit.
Yeah, and it's, how do you start to, there's probably a happy medium somewhere there versus, where we try to get everything perfect before we do any sort of release. But I think it's really interesting, and the fanatical fan base that they've created through kind of their constant updating and their constant listening to feedback was
Just to add
interesting.
to that, I think it depends on your customer expectations.
Yeah.
Like if you have, in China, for example, you have people who are willing to put up with a bunch of junk, just like we all did in the 90s with the internet and cracked applications that a lot of us helped build. But now, in mature markets, you have very high expectations.
Yeah, and this will be really interesting, especially if they do enter the U.S. market. I think the reason I like them is because it's really, there's a lot of questions about will we tolerate kind of what they have, and I think that's an incredibly valid point, but I just love it because it's how quickly can we iterate, how quickly can we improve, how can we use information to make something better. Ideally start with something great and start trying to figure out how to do this faster. And over time, how do we compress those learning loops as small as possibly feasible? Hopefully, at some point, seconds. Maybe not anytime soon.
The drug manufacturing from China will become obsolete Just that, you spend a lot of time in China, so, yeah. So we have to overcome that and
Yep.
get somebody.
Yep.
It's interesting to see also the parallels of this process happening here in this time and space. If I go back to, for those of us who remember, in the 1970s, when Honda first came here to the United States in mass, it wasn't just a pilot product. Their product was not known for quality. It was not known for reliability. What they did is they entered the market, and then they made a massive leap forward in quality and reliability. And then the same thing happened in the early 2000s when the Hyundai Kia organization decided to come here to North America. They did quickly, they built up the facility in Alabama, put out a product again that didn't have a high quality or high reliability rating, and then ramped it up to where it is today. So it's interesting to see how it's happening now in the IT technical world.
Yep.
And it's coming back around to the automotives as well.
Yeah, and it's really interesting. I think those are great parallels to kind of what's happening. So another example of this, which I'm sure people are fairly familiar with, is Zara, who's a fashion retailer. So they do things a little bit differently than a lot of other kind of companies in the retail space, where instead of putting their forecasts together and ordering 6 to 9 months of goods, shirts or whatever from Asia, and waiting and shipping them across the ocean, and they can now replace product in like 3 weeks. So they've moved their manufacturing close to the end user, and so what that allows them to do is it allows them to look at what trends are actually happening, produce in small batch sizes, and then based off of the actual consumer needs and demands and preferences. And they've used a heavy IT focus to make some of this happen. So like through RFID, they actually can track when products enter a store, when they get on a rack, when they leave the store, and so they have hyper local understanding of consumer preferences and consumer demand, which then feeds back their factory for production, and then they can make tweaks on these colors were really better, or we need to make this style change. And the other thing that happens there is in a season they change over their stores so quickly because they can produce so much faster than a lot of these other retailers, that consumers also buy, because consumers don't know if I come back in 2 weeks, will they still have this good, or probably something else won't be there. So if I think I want something, I'm going to buy it right now. And it also keeps customers coming back to the store more frequently because inventory is turning so quickly. So I think, I can't remember, it was somewhere like in a single season, their customers come 5 more times to their store than a typical retailer.
My kid said that about Zara, and I couldn't figure out why. And I think that's it. It's just a quick replacement now, otherwise it's gone.
And so imagine this: they send a merchandiser to a fashion show, they see the trend, and then 3 weeks later they have the goods in their store, versus someone who put an order 6 to 9 months ago can't react. They also don't have to discount their stuff nearly as regularly as a lot of other retailers, because they're just producing. If something flops, they don't have a whole lot of inventory on it. They just adapt and make changes. And so this has really enabled a lot through some of their IT and this hyper local understanding of consumer preferences and consumer demand, as well as bringing the manufacturing closer to the site. So this is another example. So these 2 examples are very kind of macro level at the product life cycle level. One other one that I wanted to give is this is an actual DMDII project, and this is a very micro example of every part better than the last. And so this is actually a project that's being done, led by the University of Illinois at Chicago, and it's a welding project. Doesn't sound that cool, but it's actually really awesome. And the reason it's really awesome is they've have a handful of different sensors that they've basically been able to put almost at the point of the weld. And so what they're able to do is correlate, so they have all the input parameters, and they're able to look at porosity, which is you don't want your weld to be porous, so it's a major failure mode. And what they're able to do is look at that through these sensors, predict what the porosity is look at the input parameters, and then actually feed back automatically into the controller to make an adjustment to reduce the instances of porosity. And so when you think about this as an application, this is a very, very tiny specific example of what I'm talking about, with every part better than the last. But if you can start to think about, if I can do this on a much broader scale and start to take this actual information, the sensor data, and all of the input parameters, and automatically adjust so that I don't get the failure mode that's causing me all these problems. And so this is great for this, because if anyone is a welding expert, to detect this after the fact is normally time intensive, costly. Sometimes you have to do disruptive kind of like testing. So this is a major deal for these guys.
So are they doing, do you know if they're doing this with MIG welding, resistance welding?
I would have to look at the specific. So this one's this is on a robot. So it's some sort of robotic welding.
So it would be resistance welding, then
Okay.
most likely, yeah. So they've created some type of adaptive feedback system.
Yep.
And they're measuring for porosity.
Yep.
So they also weld evaluating people welding up rope base, or is
I would,
that-
yeah, I can get you a lot. I'd have to connect with our engineer who kind of leads the project on this one. But yeah, it's so far this project is due to wrap up here in the next couple months, and it's really cool. We're hoping that we'll be able to work with them to find a commercialization partner, because it's
Space industry.
Yeah. Yeah. So it's interesting. So this is an example at a very micro level of what we've been talking about, with every part better than the last. So with that, I'm just going to leave you guys. We have 4 focus areas at DMDII. One is design and product development. Another is future factories, supply chain, and cybersecurity. If anyone has any questions about those at some point, I'd love to talk to you guys more. But hopefully this provides a sense of the types of things that we think about and where the vision that we have for U.S. manufacturers.